PhotonDust, it's our brand new particle system that's written in-house. It's written from scratch, and it replaces the legacy particle system that was a hybrid between our system and Unity, which was doing majority of the simulation. Currently, at the time of this video, it's still in pre-release testing, but it's going to be released into main builds very soon. And you can already kind of play with it. People have been doing, lots of cool things with the system. And we're going to just kind of showcase you, how is it built. And one of the reasons we also did PhotonDust is because of the performance updates, but also to kind of get more control on how the particle system works, and how is it kind of be able to add a lot of new features and a lot of tools for people to work with. And I'm actually gonna do a little primer on particle systems, because if you think about it, particle systems at their very core, they're very simple. So say you have a coordinate system. I'm just gonna do 2D one. What particle system is you have a bunch of particles. Each particle can have a position. So this one has position on the X and Y axes. I need to label my axes. So there's position. You have the position. You might have rotation. The particle might be 2D. It might be 3D rotation. It can also have stuff like size. Something like color. And there, can have stuff like velocity. So, for example, it has, this velocity, which means it's going to be moving this way. So, there can be velocity. And then you have a bunch of particles in the system. Maybe there's another one there that has this velocity. And there's a whole bunch of particles in a coordinate system. And what you do is you update the simulation based, for example, on their velocity. So if you advance it in time, this particle will move over here, and this will move over here. And it's going to happen for every single particle in the system. You can also, evolve their size or color or rotation. They can, change over time, or they can change based on, some equation. And then the other part is when you have the simulation, the particles, they're essentially just pieces of information, like the position, size. I didn't add the rotation, I'm just gonna add the rotation here. Position, size, color, velocity, which is used internally. And then you render it out, which means, for each particle, for example, you can get a sprite that you render around this point in space, or maybe, a little 3D model or whatever you want. And then, the sprite is colored, by the particle's color. So that's kind of gist, of how particle systems work, is you have points in space, and you're updating their parameters over time. They also have something called lifetime. And essentially that indicates, how long does the particle live for. So when it starts, maybe, the lifetime is 1 second. So it keeps moving, and each step, its lifetime is dropping. So here it would be, say it's 1 second here, and this is 0.9 seconds, and over here it's gonna be 0.5 seconds, and after 5 seconds, it's gonna disappear. The lifetime is also something that you can use to drive other parameters. So for example, say you want the particle, to fade in and out. So what you're gonna do is you're gonna define, some kind of function. How does the color of the particle change over its lifetime? And you can essentially say at the beginning of its lifetime, if you were, say this is, alpha. And this is, when the particle starts living. This is when it dies. That's 0.1 seconds. And you're going to say, the particle, you make a function that's when the particle starts living, it goes, from transparent, it becomes visible, then it kind of exists, and then sometime, before it dies, it's going to fade out. So that's, for example, one way, to map its lifetime you know, to like a property like the alpha or color. It could also be size, you know, like it could, you know, start tiny and kind of, you know, and then kind of, you know, get big and then get small again. You can also do multiple parameters. So for example, you know, you can do alpha like this, so it actually fades in and then fades out, but also you could do something like size over time where it just keeps growing. So it can start, you know, at certain size and it just keeps growing. And it dies, you know, at certain size. And you have created mapping between the lifetime and the size of the particle. There's lots of different ways, you know, to create mappings between these properties in order to create all kinds of effect. Like if you think about it, for example, like a smoke effect. So you have like, you know, you have a sprite that's a smoke. You know, it's some kind of smoke sprite. And for each particle, it fades in when it appears. So it doesn't just, you know, pop into existence. It stays, and then like, you know, it fades out. And you also combine it with the size, so it starts small and it kind of expands. And as a way, you know, you can combine two effects, you know, to get like a smoke effect or lots of different ones. You can also do, you know, lots of other effects. For example, you can have, you know, you can apply forces to them, like turbulent force. So instead of the velocity of the particle just being the same, you know, let me actually do another one over here. So let's say one starts here, and the particle starts moving this way, but maybe, you know, there's a force that like when it moves over here, the force now moves here, which means next time it's going to be here and the force rotates this way. And next time it's going to be here and the force rotates this way. And it makes the particle kind of follow, you know, some kind of turbulent path because the velocity itself is changing over time. So there's lots of things like that we can do, you know, with the particle system. I'm going to clear this out. The way PhotonDust is designed is you have some base properties. So you have like, you know, you have the position, you have rotation, you have scale, and you have color, and then you have also like lifetime, which is like how much lifetime it has overall. Lifetime. So those are some of the kind of built-in properties that particles have. And these, every single particle is always like gonna have. Some of them can be just, you know, default, but they are kind of part of PhotonDust. And there's starting versions of these. When the particle is first created, when it's essentially emitted from an emitter, it initializes the starting values. So for example, the emitter can, you know, it gives the particle position. So like if you have a sphere emitter, you know, like that's emitting particles, it can be emitting, you know, particles within its volume. It will give each particle a position within that volume. And it's, you know, the job of the emitter to do that. You can have rotation, you know, scale, color, they are all kind of initialized. And for example, for color, you can have a module. I'm kind of skipping ahead a little bit. Or just kind of back a little bit. The way PhotonDust works is you have these basic parameters and you have a set of modules. And modules that can do multiple things. Some of them will initialize the starting properties. Some of them will calculate new properties during the particle's lifetime, and some will kind of, you know, do a mix of both and do like more complex stuff. So you have modules which initialize some of the properties. So for example, you want each particle to start with a unique color. You can have a module that computes color for any new particle. There's a mix between two different colors. Or maybe it picks it from a texture, you know, or maybe it does some equation to compute it. Or maybe you're like, you know, sometimes the emitter can like, you know, also contribute a color if it's like a mesh emitter. Or if it's like an emitter which has some, you know, equation to compute the initial color for the particle. What PhotonDust does is it has, you know, a bunch of these starting properties, but it also has sort of output properties. And for those, you also have position, you have rotation, you have scale or size, and you have color. And there's also like another one, I'm not gonna, well, I added here, which is like a frame index. You can think of it as sort of like UV coordinate. you don't have to worry about this one super much. These are like really the main ones, because this is what is needed to render the particle. You're essentially gonna render the particle at certain position in space. You're gonna render it with certain orientation, at certain size, the size is 3D by the way, and with certain color. And these then go into a render module. So this goes into a renderer. And the renderer is essentially responsible for taking this data and making the particle appear in some way. And it can be like a billboard, you know, so it's like a billboard sprite. So there's like there's specifically a module called billboard renderer. There's also like a mesh renderer, which for each point is gonna, you know, render some kind of mesh. And there could be like, you know, more in the future. Like one that I kind of want to add at some point is one that actually computes a mesh using something like marching cubes to sort of create like a, you know, a surface. So you can do stuff like that looks like liquid. And there's like, you know, kind of lots of like opportunities like, you know, for additional renders there. But the gist of it, they take these, they make sure it's rendered out. And then the PhotonDust itself, it will take stuff like the emitters to add new particles to the system, and then we have a bunch of modules which take these and compute these. One of the important modules is the position simulator, and this is a typical way particles are simulated. But unlike the particle system that's in Unity, PhotonDust is very modular. So there's like, you know, there's lots of different ways the initial properties can be transformed into these output, like render properties. But just to kind of keep things simple, you have the position module. So I'm gonna just be position module. And the position module, what it actually has, you can notice, like, you know, in the starting properties, like, you don't really have, you don't have the velocity. And it's because there's lots of different ways to compute position, and the velocity is specific to the position simulator module. So the module can actually add its own internal buffer, which is velocity. And that velocity can also be initialized from starting properties. You can have like module that, you know, for example, assigns a new speed that's like, you know, between minimum and maximum. There's also like one initial property that I omitted called direction, or sort of like initial like vector. So the position module, when a new particle is added, it will take the direction to compute initial velocity, and that will then get multiplied by any initializer module to kind of like, you know, compute the initial velocity. What the position module will then do, that every single update, it will essentially compute a new position for the particle, and it makes the particle move around. And you can have, you know, another module like, you know, color over lifetime. I'm just gonna go color lifetime. And what this module does, it will take the starting color and it'll do something with it, like it's gonna multiply with some value, and then it, you know, computes the output color. And can do whatever math it wants in here. You can also chain those modules. So like if you have multiple modules, so you can have like, you know, one, and there's like, you know, another one that like simulates color in a different way, or maybe just does, you know, does the alpha channel. And if you have multiple of them, it'll take whatever is computed, do whatever own math, and then, you know, assign the color. It's sort of like a chain. Which is like why for PhotonDust the order of modules matters. The same also happens for initializers. If you have something that computes the starting color, it's gonna, if you have multiple of them, they're all gonna contribute, and their contributions are multiplied with each other. So this is the kind of general gist, you know, of how PhotonDust works. Is we have some starting properties, we have some sort of like lifetime kind of properties. So like for example, lifetime, I kind of simplify this one a bit, because there's actually there's a starting lifetime, which is just, you know, how long the particle is supposed to live, and then there's like its current lifetime, which is how much it has left to live. And some of these properties change during the lifetime. Some of these are specifically starting ones, and the ones that end up changing are like, these. So this kind of should cover, this should kind of cover like, kind of the basics. You have like the starting properties, you have some lifetime properties, modules modify these in various ways or initialize these. It computes, final properties, and then those go into a renderer that like shows the output in some way. I'm actually gonna do a showcase, and I'm gonna switch this one to first person camera. Oh, and you can see my hair. Give me a second. Wrong one. There we go. So you should have the Froox view now. And you can see Sarah over there. And I'm gonna spawn a developer tool from the inventory from Resonite Essentials. So this is the developer tool for anyone who's not familiar with, and I can start creating. So if I go open context menu, there's create new, and you see there's the legacy particle system. During testing, both systems are available. And if I spawn this one, you see this isn't called legacy particle style, it's just to kind of give people idea this is gonna go away. But this old system, it's very monolithic. Everything like is kind of bunched up in one place, which makes it a little bit kind of harder to work with. It's also like hard to extend because, for example, the size of the particles is initialized, it's always min and max, and makes it harder to do lots of different methods to, initialize those. I'm gonna get rid of this one, and instead I will create a new particle system. So this one's gonna be PhotonDust. And you see over here, you have the particle system. That's the actual handler of the simulation. So this is like, what's triggering all the simulation with particles. But in order to simulate them, it uses a particle style. Particle style, it defines, how the particle system behaves and how it looks. Each particle style is going to have specifically a renderer, and you can see it actually says billboard particle renderer, which is what I talked about. Oh, why cannot I? Oh, my controller was weird, sorry. Which is essentially what I was talking about here. And that's responsible for rendering these particles, in the world. There's also a number of modules, and initialized it with a few basic modules, so, just to give it some initial behavior. And you can see, there's a few of them. And the modules are the ones that actually do stuff in the particle system. You see there's the position simulator module. If I actually make it go away, you see now it's emitting particles, but they're not moving around because there's nothing that would be moving them, so they stay at their starting position. So I'm just gonna undo that. Then you see the sunlight burst out. There's also a bunch of stuff that's been kind of organized here. So a lot of these modules, they've been put under these slots. It's not necessary to put them there. I made it this way just so it's kind of easier, so you don't have like, a million things in one place. So I can be, this is the emitter, this is where the particles come from. And if I move it around, it changes where the particles come from. I can change the rate of emission. I can be like, add more there, or the 1,000. And I have a bunch of particles here. Ooh. I can change the color for this one, for example. This is like a new thing somebody mentioned. I just made it part of this emitter. And when I'm changing this is actually the emitter itself, which is giving the particle its starting color. But you see, it's still being kind of combined because the particles, when they were white, you see they go from white to black. And the reason they do that is because of the initializers. There's specifically color range initializer. And what this does, it picks a random color between minimum and maximum value. So if I change this one, you see they're now getting a random color that's a linear interpolation between these two. And this doesn't depend on the emitter at all. That's the module giving them, that value. I'm going to change this one back to black. It is being combined. Not all emitters have this. The point emitter has, a single color. So if I assign it, it multiplies the color, which means they still go from fully bright to black, because that color by the initializer is being combined with the emitter color. I can also add other emitters, so I'm going to actually get rid of this one, and you can see like it stops emitting because now there's nothing that's introducing new particles into the system. If I go under rendering, particle system, emitters, there's a whole number of them, and I'm gonna pick, I'm gonna use box emitter, because that one has like a bunch more color options. So for each emitter, you need to assign it the system that it's adding particles to. So I'm gonna open this one next to this, and I'm gonna take reference to this and drop it here. And you see, now it starts emitting new particles. And I'm gonna increase it a bit. I'm gonna do 1000. And you see now instead of emitting from a single point, the particles are actually emitting from a box volume. It's a little bit hard to see, so I want to slow them down. So I'm gonna go back to the initializers. And there's a speed range initializer. So I'm just gonna drop it to lower values so they don't go too fast. And you see, like, you can better see the box shape of them. What you can also see, if I go back to the emitter, this one has its own method, to give them initial colors. So I can, for example, color each vertex of the emitter. So I can make this one red, and I'll make this one blue, and this one green. I think that's not quite enough particles. I want a bit more. So what I'll do, on the particle system, you also have a limit, you see, like, we're actually reaching how many particles the system can have. So let's just add extra 0 there. There we go, we can get more particles. And let's see how many we have. We have about 3000. We can bump it up a bit more. Let's do like 5000. There we go. And now it's going. Now it's going. I might actually, some of them like live a little bit too long, so what I'll do, go back to the initializers, and there's, lifetime range initializer, and I'll just set it so like they live 1 second, because right now they were living between 1 and 5 seconds. So that now they don't live too long. And so we can kind of get a kind of box shape, and it's kind of volumetric. So like if I go inside, it's full of particles. Each of the emitters, they have a bunch of properties, so you can kind of control how they move. I can, for example, say this one to emit from shell. So now instead of being emitted from the entire volume, it's sort of like a shell of a cube, and they're still kind of being colored. So what you have in this case is you have the emitter, and you can have multiple of these, which is adding new particles to the system. The emitter can also provide some of the starting properties, like the color in this case, and the direction. And then you have initializers, which modify the starting properties. For example, the color range initializer takes, the color from emitter, it multiplies with additional color. The size is initialized, the particles are different sizes. The speed is initialized, lifetime is initialized to something. And then you have simulators. And the simulators, they are what is responsible, for updating the particles over the lifetime. And right now there's only the position simulator module. That's what makes the particles, move, because each update, it computes their new position based on the velocity, on their velocity. It has a few properties on itself. It can, for example, do collisions. So like if I enable that, you can actually see an interesting effect here, because now all of the particles are computing collisions. And what you see is, we might need like a bigger collider, like a box or something. What you see though is it's running at lower frame rate, but it's actually the particle system itself is running at lower frame rate than I am. So like if I switch this here, you see like I can still move at a faster rate than the particle system is updating on. And this is one of the big improvements that PhotonDust has over the previous particle system, is it's asynchronous. If you make the simulation too heavy, which is like, in case, of having too many particles. I'll actually make some modifications so we can see the collisions better in a sec. If you make the simulation too heavy, instead of this being your frame rate, instead, of us running at the frame rate of this particle system, it's only the particle system that runs at a slow rate. All of the simulation, it happens on multiple cores, so this is gonna, is multi-threaded, which the previous system was mostly as well, but it's also specifically asynchronous. Let me modify the properties a little bit. So like, I would actually want the particles, let's make them fall to the floor. For that, we actually want something that's gonna update the velocity. So I'm gonna add a gravity module. So I'm gonna add attach component. Because when you think about it, like what gravity is it's modifying the velocity every frame. Like if the particle starts moving, this way, let's see, where did I leave my brush? If the particle has some velocity, gravity is a force that's modifying that velocity, is essentially acceleration that's pulling it down. So as the particle, it moves over here, and the direction moves a little bit downwards. And then like it moves over here, and the direction moves more downwards. And then moves over here, and direction more downwards. And then moves here, and direction's now almost aligned, and essentially then ends up like, falling. It's because like there's a force that's being applied to the velocity that's, making it move downwards. And it's also accelerating because it's an additive force. So every update, the velocity is higher and higher and higher, which means it moves faster and faster. So if I go to rendering, particle system, modules, these are probably gonna get more organized after like some time in the release. But I'm just gonna add a gravity force. And then what I need to do is I need to open the system itself. When you add a module, the module can actually, each module can be shared between multiple particle systems. So you need to be able to tell the particle style that you want it to use this module. So what I'll do, I'll just add a new empty space for here under the modules list, and I'll drop it here. And the particles start falling down. And now do we have a nice collider. Just put it in. Make it a little bit bigger. I might need to have them live for a bit longer because this is a little bit harder to see, and make them a little bit less dense. So I'll do this. This one is particularly bad like on collisions. So there's just this many, and I'm gonna make them live, say for like 4 seconds. There we go. And you should be able to see they should be like rolling off. Wow, this word is really bad for collisions. I think it's because there's like a lot of colliders and stuff in here.
Does this query any Beppu structures?
Yes.
Okay.
Yeah, all the collisions that's against Beppu because this is the physics engine we use. I'm gonna make this smaller so it's a little bit easier to see. Oh, hold on. So it's easier to see. Let me also reset the colors so it's I should have been doing, hold on, let me just drop this here, just so it's kind of nicer to see. There we go. And you see the kind of like, colliding and flowing there. And if I go back to the simulator and disable the collisions, they will like, start falling through. And you see that it runs a fair bit faster, but now it's, not colliding anymore. But that's one of the benefits is like, if you had like worlds that are particularly not friendly, to collisions, this would like, if this was the old system, this would be killing our frame rate. But we can still kind of run, and it's just, it's only the particle system itself that degrades. Let me lower this a little bit more. I'm just gonna do 100. So if it's fewer of them, it has like fewer to simulate. You see like it actually starts running faster as they kind of bounce around.
Mm-hmm.
I didn't expect this war to be this bad for collisions. It's actually one of the things that I kind of also expect that we're gonna get like a significant improvement on once we do the switch to .NET 9, because Beppo Physics is specifically optimized, you know, for modern .NET, and it's running way slower than it can, you know, with the mono. We even had to do some things to make it run reasonably fast. But like we're not anywhere like tapping its full potential. So like there's gonna be one of those things that's gonna be interesting once we make the switch and we're actually running with .NET 9. I kind of expect the simulation to happen a lot faster when there's, you know, lots of physics, like, you know, physics interactions, but also in general because it just generates way faster code. But you can kind of see, you know, the particle system, how it's kind of like, you know, doing its work. If I switch back here, I can show you some more modules that I can do. So one of the things, I'll change the initializer. I don't want to be like, you know, that dark. I just want to be a little bit. There we go. Another bouncing over here. There's lots of new effects that were not possible to do before with the old particle system, and ones that particularly benefit from the modular nature of the system. So I have added, like, you know, a module that simulates the force, which essentially, you know, just modifying the velocity. Let's add one that modifies the color. So I'm gonna do attach component, rendering, and I'm gonna do modules. This one's like my favorite because it makes cool visuals, is color HSV over lifetime start end. So there's lots of modules, you know, that will modify the color somehow. But I particularly want this one, because what this does, it changes the color of the particle based on how long it has lived. And it changes it in the hue, saturation, and value color space. Which means if it starts at 0 hue and ends with 1 hue, it goes through the entire color spectrum. So I have added this module. Now I just need to like add it to the particle style. So I'm gonna take this, I'm gonna drop it here, and whoop, and you see it immediately starts coloring the particles. I kind of like this effect. Like it looks pretty.
It's like Skittles.
Skittles. You could even do things like, you know, if I set it to 2, then it's actually gonna cycle. Making them go all around. It's actually gonna, you know, go through the hue like twice. So you see it starts red, gets to red in the middle, and then like goes through the spectrum again. So like you can play, you know, with these properties. You can also, like, you know, just have it go through just part of the spectrum. So, you know, this one just gets from red, you know, all the way to green. The important part is also what this module is doing. If you look, I'm gonna position this. This might be actually a fair bit distracting, so I'll move it. I'll move the emitter from here. Where do I move it?
Can we make them have shadows?
You can with the right render. I'm just gonna move it over here. Have them bounce over there. There we go. Or maybe here. Now they're going on the desk. So what this module is doing, and I have a bunch of clutter here. And I lost my brush. Oh, there it is. What the module is doing, it's taking the starting color, which is initialized by the initializers, and then it's computing, it's taking the current lifetime, seeing how long the particle has lived, and it computes a new color based on that lifetime, multiplies it with a starting color, and then, you know, writes it into the color to be rendered. And that's kind of how it's achieving its work. You can also combine multiple things. I actually have a request. Sarah, would you be able to like bring me like a gradient texture? Whatever gradient texture like you would like.
Yes, I do have one actually.
Do you have a cool one?
I do have a cool one. Let me see if I can find it here just real quick. Aha, here we go. Here's all of the colors of the rainbow.
Beautiful. So, where's the colors of the spectrum? Which is pretty much, yeah, that's pretty much rainbow. So what I can do, I'm gonna switch this back into smooth POV. what I can do here is add another module. I'm gonna add another simulator, and if I go here, I'll add rendering particle system modules. There's also color over lifetime texture, and what this module does, it assigns it instead of like, you know, the color being computed mathematically, it will read it from the texture, you know, going from left to right. One thing I need to do in order to use this texture, I need to make sure it is readable. So I'm gonna open it in Inspector. Let's see where the texture itself is. I could have just opened from there. I'm just gonna open it here, so I'll grab this one. Get rid of this. Oh, this is a procedural texture. Okay, I thought it was a big one. So this one's already gonna be readable because procedural textures are readable by default. Yeah, so I can literally just grab this texture and drop it here. And I'm gonna open. I should have probably just kept this. Oh, no, I have it open over there, so I'll just grab this. Let me just pull this out. So I have the particle style. And I'm actually gonna replace the module first. So I'll put this one here. And you'll see it's actually, as the particles live, the colors are going, you know, through the values in this texture. So you can add, like, you know, whatever you want there. Like, I could literally even do this, you know. This is probably gonna be weird, but I could take a picture once it loads and drop that in there, and it's gonna, you know, it's gonna use those values to color those particles. This one I do need to make sure it's readable. So I need to check readable. I need to check uncompressed. There we go. Now I can drop this here. It's only gonna use like a strip of it, so it's gonna be a bit weird, but you can kind of see, you know, it's getting the colors from this texture.
Oh yeah, it's just going along the top.
It's going along the top. I do want to add a module that like lets you kind of like, you know, randomize like which part of this also kind of comes through. So there's gonna be more options for that, but you can see kind of in action. But I'm gonna drop this back in, and actually I have like another request. Can you find a texture that's also like a gradient, which is a color gradient, but it doesn't go through all the colors. It's only a few colors. Find me that one, and I'll show you like another effect, which comes, you know, with combining the modules. So this module, each one essentially is like, you know, doing something to the colors. If I take this one and I also add it, you can see it doesn't quite like look like much, because now the colors are getting multiplied with each other. So what I'll do here is instead of changing the hue, I want to keep the hue the same. So now it's actually starting like, you know, it's literally just the red hue for the whole lifetime, and it gets multiplied with the hue on this one, and because it's red, any other color gets masked out. But what I can do is I can also remove the saturation, because I don't want it to be like, you know, kind of saturated at all. And now I can change the values. I can, for example, set a start value to be black, and you see like it's kind of combining the contributions of these two to produce the final color. But what also matters is, you know, which order these modules are in. So if I swap them, oh, actually for this one it's not gonna matter, because the multiplication is always the same. In some cases it'll like matter, because depending, you know, on the order of operations, that's gonna produce you different results, but in the case it doesn't, because it's a multiplication. But you can kind of, you know, you can stack multiple different modules to like, you know, produce behaviors. As I'm checking on the time, I'm actually gonna speed this up a little bit, because so I would like skip over the other texture stuff, because there's a few more things I wanted to showcase. One of them is, you know, some of the kind of turbulence stuff, because those are really cool effects. And I see we have a few questions as well, so I'll try to get those in a sec. Let's switch this back to the camera. And I'm gonna bring the emitter over here. And I will remove one of these systems. I think I've closed it. I always close things without thinking about it. So get rid of this one. I'll change this. Simulators. I'll change this one to have the full saturation.
I couldn't
full
find the color
volume.
one, but I can.
No, it's okay. Like I'm gonna skip that part right now because
Okay.
we're kind of running short on time. And also I'll get rid of the collisions. Then I will lower the gravity. I don't want it to be that strong. There we go. So one of the cool effects, no, they cannot go in like this. One of the cool effects also, there's a new turbulent force. So you have the gravity force, but we can also add under rendering particle system modules, there's a turbulent force. Oh, actually, I think it's called simplex turbulent force. There we go. So I add that one. I will add this module, simplex turbulent force. And you see it kind of starts, the particles start kind of like, flowing a bit different. And you can like, mess with these settings, there's like different ways for it to work. So like, you can, for example, have it like, alter direction. And see now the particles are going, doing this thing. And maybe you can make it stronger. And maybe I want it to be like, do like this kind of thing. And maybe increase the scale, so like it's a little bit more kind of varied, and this one actually might be too strong for this. So you see now they're kind of like doing like this kind of more complex behavior. I'm not gonna like mess with it too much because like there's like you can literally spend hours like just messing around with this, producing all kinds of cool effects. But you see the particles, like they can do a lot of kind of cool stuff. There's like one more thing I'm gonna actually show you, because I wanna give a little bit more kind of background on how it works. Like each particle, it can have, it has its own render, but there's also specific modules which are also their own renders, and they add like additional rendering to the particle system. One of those is the trails module. So if I go back to Smooth POV, I'm just gonna add it to the root. Rendering particle system modules. There's the trails module. Where is it? Trails particle. Oh, it's particle trails module. There's particle lights module, ribbons, trails. I'm gonna show you the trails one. So there's the trails module, which has also a bunch of stuff. I'm gonna just give it the same material for the time being. There's lots of options to play with, and we don't really have time to like go through all of these. But I'll assign it here. And now you see the particles actually start drawing trails, which is like, it looks really neat. And if I now start like, messing with like stuff like the forces, I'm gonna go simulators. I'm gonna make them, stronger. Oh, this is weird. This is just turned into a clump. And change the scaling on it, on the turbulent force. There we go. You see now it's doing all these cool things. And if I change the force offset, it's gonna do like. Oh, that is weird. You need to mess around with it a fair bit. Might need to like lower the strength so they're not like too constrained. Or do this kind of thing. Oh, that is neat. Yeah, I'm kind of getting into the. There we go. This one's supposed to go this way, and I'll change this one. There's lots of different things you can kind of do. Like you can just mess around with it and do all kinds of effects. But what I wanted to show you with this one, there's also like modules where there's modules where actually sorry, can you move them a little bit somewhere so they're not in the way? I'm just gonna clean up. I think I kind of showcased like enough. There's like, I underestimated how long this is gonna take, so I do want to get like to some questions. Okay, they are over there now. It's fine. Oh, they're going a little bit over here still, but it's fine. It's fine. So there's also like modules, which kind of act after the main modules do. So like there's a Trails module. Trails. And what this module does, it will, this is something called internally a follower module. And there's a few of these. And what it does, for each particle, the particles can be followed by additional effect. In this case, a trail. And what it will do, it will essentially look at the final simulated position, and it has its own internal data. There's like the trail data. I'm not gonna like go super into details on this one because that's also like a rabbit hole. But it'll trail data, and it'll take the color, it'll take the position, it'll combine it to compute its own data, and then this one has its own sort of built-in renderer. There's also the particle lights module, so it's gonna, some particles are gonna have like actual light in the scene. There's the ribbons module, which is similar to trails, but instead of the trail kind of following the path of the particle, it kind of goes through all of the particles, and each of the modules also has its own additional modules. For trails, there's also initializer modules, which are going to initialize some of the properties. They can be simulation modules, which can also modify the trails, over lifetime. There's not really many, but there's going to be lots that will be added over time. But overall, this is the general structure of the particle system. You start with some, built-in properties. There's emitters, which add new particles. They can initialize some of these. And there's modules. Some of the modules are going to initialize, starting properties. Some of them compute the properties, every frame, either using the other properties or using whatever internal math or, whatever structure. And then those then get computed to the final render properties, which are then rendered out, as individual points or meshes. And some of the modules, they can follow the particles, they can do some extra stuff, and they have their own renders as well. And it's kind of how the particle system's kind of put together. And one of the reasons is it makes things, it makes everything a lot more modular. Because if we want to change how color is computed or how position is computed, because the reason I did this is I was actually inspired by the Minecraft particle system, which was shown to like one of my friends like a while back. Torn, he showed me the Minecraft particle system, which is a very interesting approach where you can define, instead of simulating velocity of the particle, you actually define equation where the particle is based on its starting properties. And that's something I want to add to PhotonDust at some point. So instead of velocity-based simulation, you define an equation that's, for example, based on position, rotation, direction, and lifetime, and you just say, based on these, this is the position of the particle. And it's going to open up, lots of kind of cool effects where you can sort of procedurally define, how the particles move around. And all you need to do is just swap out this position simulation module for the different position simulation module. So the system is designed to be like, very flexible, very expandable. Some of these modules, like for example, the turbulent force, it literally, like it took like it was less than an hour to like write it. I think it was like, with a simplex function, like it was something like 5 minutes. It's very easy to write lots more modules, which means once the system is out, like we can add lots of cool effects. If you have like specific way you want to like the particles to behave, you can make requests, and now we'll be able to fulfill those requests much faster and much easier than we would have been with the old system.